If you use Pandas at all, you need to know about this library that can literally give you a 150 times performance increase with no code change. I'm not exaggerating. This library is the Rapids cuDF library provided by Nvidia, and I've teamed up with them in this video to demonstrate how easy it is to use and the massive performance benefit you can get. Obviously, this is free. You don't need to pay for anything, and I'm going to show you here how it works and how much faster it is. Now, as a quick primer, the Rapids cuDF library is a Python GPU data frame library that's aimed at accelerating data science workflows. Now, what this allows you to do is unify the CPU and GPU experience, so whenever you can't use the GPU, it will just default to using the CPU. Now, what this also allows you to do is continue using Pandas when you have massive data sets that traditionally wouldn't be feasible to load on the CPU. A lot of people, when they use Pandas, had the issue that as soon as they got into big data sets or a lot of kind of heavy computation, they had to move away from it because they just couldn't utilize it in their workflow. Now, when you have this massive speed increase in this library, or specifically the update to this library, you're actually able to continue using Pandas, which is the tool that most people love to use. So I'll leave some links in the description so you guys can check it out for yourself. One of them is going to be this right here, which is the notebook that kind of demonstrates the use case of the Rapids library. Now, it's the new update to the Rapids library that came out about a month ago that really brings this huge performance benefit to Pandas, but Rapids has been around before as well. Anyways, as we go into here, you can see that there's just a few commands. We got to obviously install cuDF. Once cuDF is installed, we can simply import it, and then we can literally just use cuDF as if it was the Pandas import. So that's one way to use it, but another thing that you can do is there's actually a command that you can run that simply changes over Pandas, so any import to Pandas or third-party libraries using Pandas, to just use cuDF. So if you look right here, it says load extension cuDF Pandas. When you do that inside of this kind of Jupyter Notebook environment, now any import to Pandas, whether your code's calling it, any other code is calling it, will just default to use cuDF. The way it will work is anything that can be accelerated by the GPU, it will just accelerate it, and it will just be a lot faster. Anything that can't, it will default to use the CPU, so you're not going to have any breaking code. Everything literally just works. Let me just get these examples set up for you here, and I'll show you how much faster it is. All right, so here's a quick demo just in the collab notebook. You see analysis using standard Pandas. Won't read through all of it. We imported Pandas. I downloaded a data set that's about 455 megs. And we can go ahead and run it and sample the first 10 entries that are in our data set. So give this a second to run here. You can see already it's being a little bit slow. Okay, so we've got 10 entries in here. Now we can try to answer some questions related to it, right? We can do some grouping, we can sort some indexes, some data science stuff that I'm sure most of you probably know more than I do. Anyways, as we go through here, you can see there's some more things like which vehicle body types are the most frequently involved in parking violations, etc., right? We can go through and kind of run all of these different things. Now, what we can also do is time this. So what I'm going to do is just run this and get how long it actually takes to kind of go through this pipeline of operations. Then we'll compare the same thing later using the cuDF library. All right, so this took 9.93 seconds on the CPU, a total of 12.7 seconds. I'm not sure what the wall time means, but it says 11.6 seconds. Anyways, we have another timed operation, which is this group by. If I'm not mistaken, these sometimes can take a little bit longer. Actually, I guess I was mistaken. This took 4.53 seconds. And if we go down here, this one, let's give it a second here. Looks like it's going to take even a little bit longer. Took 6.33 seconds. Okay, nice. So now let's use cuDF. So what I'm going to do is just run this. Load the cuDF extension. So cuDF extension is loaded. And now whenever I import Pandas, we're going to use cuDF. So we can time this one now. When I run it, you can see this takes 1.13 seconds. When I run this here, 24.8 milliseconds. Run this one here, 140 milliseconds. Pretty much happens instantly. Now, there's a bunch more stuff in this notebook if you guys want to check it out, but I also want to show you my own custom demo in the installation process. So let's get into that. All right, so I'm just on the Rapid cuDF's GitHub page. I just quickly want to talk to you a little bit about the installation. This is going to widely vary depending on the operating system you're on, but obviously you're going to need an Nvidia capable GPU, and you're going to need CUDA installed on your system. Now, this will work in some kind of Linux environment. If you're on something like Windows, like I am, you can use WSL. There's just a few more setup steps there. Anyways, as you can see here, there's install. For this to work, again, you need CUDA, you need a Linux environment. that's kind of the basics. You obviously then need to have Pandas installed, and then you need to install the Rapids cuDF library. There's a few ways to install that, one of which is to install it using Conda. So you can see here, it gives you all of the requirements and then gives you the Conda install. So in my situation, all I did was I opened up WSL, I enabled CUDA inside of WSL, I installed Conda, and then I just installed the Rapids library once I updated my Python and did all that kind of stuff. I'm not going to bore you with that. If you guys are going to use this, chances are you're going to have to go through your own installation process anyways. Point being here, we have two demos, right? First demo here is just using Pandas. I'm calling this demo slow. I can do Python demo slow.py, and you see that this works, okay? It just prints out information about some tip percentages or whatever using Pandas. Now, the normal demo here is not going to be any faster because we're not really doing anything that uses the speed increase. The point of this is to illustrate to you that all I have to do is change out import pandas from import cuDF. And now, rather than doing pd.readcsv, I'm just doing cuDF.readcsv, and this will now work. So if I do demo.py, we will get the exact same result. And you can see we get the same result. Now, just as a quick note here, you don't actually have to import cuDF like I have here. What you can do instead is simply run the Python command with a specific argument, and it will actually automatically kind of override the pandas import for you. So I showed you that we could just use cuDF, but instead what we can actually do here is we can say Python 3, and then we're just going to put this argument, which is -m, and then cuDF.pandas. Then we'll put the name of the file we want to run, so demo slow.py. Now that we're doing this, we're going to run it with cuDF enabled, and I actually had 0 code change. So let's go ahead and run that. So there you go, all functioning correctly. Throughout the rest of the video, you'll see that I do have cuDF, for example, but again, we don't actually need to change it to cuDF. Instead, we can just use this manual argument that I have here. Now, if we go here to the real demo, what I did is just set up a little bit more advanced code, and I actually downloaded a fairly large CSV file. This file, I believe, is about 1 gigabyte. And as soon as you start using files that are over about 500 megs, and you start to do some sort operations, mean operations, things that are doing a lot of aggregation or a lot of different operations on the data, that's when you'll really start to see the performance impact. So what I'm going to do is just run the regular demo here, so real data demo, and just kind of show you the speed. I'm doing a bunch of operations here, like getting the mean, getting high severity, sorting, grouping, and then applying a function to all of the different rows inside of my data. You don't need to worry too much about exactly what's going on, but you're going to see the drastic speed increase. So I'm going to say Python 3 real data demo.py. This is going to take a minute to run. Once it's done, I'll be back. I'll show you how long it took, and then we'll compare it to the faster cuDF enabled version. All right, so I just ran the demo here. And you can see that we're getting, 0.46 seconds, 0.39 seconds, 19 seconds, which is actually quite a bit of time, especially if we had a larger data set, 0.49 seconds, 1.64 seconds. Okay, so the main thing here was the sorting, which took a while. So now what we can do is run the exact same command. So Python -m, cuDF.pandas this time, and then the real data demo.py, and you'll see that now we'll enable cuDF, and you'll see how much faster this is with no code change, just adding cuDF.pandas. All right, so this is finished now, and you can see we're getting 1.2 seconds, 0.02 seconds, we're getting 0.4 seconds. It's almost a 40 times speed increase from the previous one. We're getting 0.28 seconds, and we get a bunch of other ones, right, that are quite slow, 0.53 seconds, etc. So not quite 150x on every operation, but for something like sorting, you can see that we're getting a huge performance impact by literally changing nothing. We just ran the command using cuDF.pandas. Now, for some reason you're curious about the data set here, this is some US accident data. So we've got some stuff like weather conditions, severity of the crash, start time, visibility, temperature, all this kind of stuff, trying to get some trends based on that. Anyways, not super important. Just wanted to show you the demo here and really illustrate the power of this library. Obviously, it is completely free, and a big shout out to Nvidia for sponsoring this video and for coming up with tech like this, because this is quite incredible and I'm sure is going to help a lot of you. Now, I've left some links in the description. One of those links that I left, let me see if I can pop it up here, is actually a link to the AI and Data Science Virtual Summit. Now, this already happened, but there is a bunch of replays of some really interesting events here. So if you guys want to check it out, feel free to do that. This is pretty much just talking about AI, data science tools, innovations in the space, etc. I'm sure you guys might find some value in it. All the links you need to get started with cuDF are in the description. I hope you guys found some value. If you did, leave a like, subscribe, and I will see you in the next one.